Most AI systems look simple in demo. User asks a question, model gives an answer, and demo works. And it feels like product is ready. But production system does not work like that. Let me explain this with the help of 4 diagrams. In demo, the flow looks clean. There is a user, model, and you get the answer. Right? User asks questions, model gives answer. In demo, you have one user, clean prompts, permission is not needed. You don't have a stale data issues, no retry issues, eval is not there, no latency issues, cost pressure, you don't care, right? And no SLA. So demo looks quite clean, and that's why demo feels easy when you test a demo application. It feels quite easy, right? Now production is different. In production, many users using the system at the same time. Input could be messier, document could be stale, you will have retries issues, evals need to be there in place, need to take care of version drift, there will be regression risk in the system. Access control matters, some answers need citation, some actions should be blocked, and some request will be expensive, some request could be slow. So the real flow is not user to model to answer. In production system, the real flow is user to product, product to multiple system, then model, then validation, and then maybe actions or user get the response. Now let's look at the production AI system. So in a production AI system, model is there, but this is one box. Before this, there is pre-flight system. So user request comes, it goes to pre-flight, and in this system check happens like who is the user, which tenants this request belongs to, can this user see this data, what is token limit and rate limit applied to this user, is this read only request or can this trigger any action, right? So once this check happens in pre-flight, then it goes to context system. In context system, RAG, search, documents, database state, memory, tool results, and application context comes in. And this part matters a lot. If wrong context goes into the model, the answer can still look confident, but it will be wrong. And the better model can make the wrong answer look more polished, but it will be risky. Next is model. Model runs, it generates text or it makes a tool call. After model runs complete, the flow is not completed yet. Next is validation, and validation needs to be done to check if the response is grounded to the context which was provided, the citation is correct, tool call is allowed or not, the argument in the tool call is valid or not, is this action safe, should the system ask for permission before doing anything. So all these sort of checks is validated over here in this system. And then next comes the execution. So maybe the system just return an answer, or maybe it makes API call, or it creates ticket, it sends email, it updates internal database record, and it can take actions, right? So it can make updates to whatever system you allowed to. And this is where AI become dangerous, because wrong text is one problem, but wrong actions is a bigger problem. Without observability, debugging is almost impossible. When something goes wrong in production, team can only say model gave the bad answer, but that will not help. What you want to know is, was the prompt weak, or permission was missing, or context was not correct, wrong context was fed to the model, or validation was missing, or in execution system tool call was unsafe. So if you don't have observability in place, you don't know where system broke and why you got the unexpected result. And sometimes you also want to know if model returned the uncertain answer, but product still decided to return that to the user. So model is one part in your entire system. Model is not the product. Model is one part in your entire system, and what you build around the model is the real product. Next diagram is same model, two products. Same model can produce two very different products. Product A using the same LLM, but it has weak system boundary. It has bad context, no permission checks, no validations, no observability. So this product can answer to wrong context, leak data, make wrong tool calls, return the answer which is not validated, and anything goes wrong, you don't have observability in place to trace what went wrong. Whereas the this product, this has good system boundary, it answers with good context, it has permission checks in place, it does validations after the model reply with the answer, it has fallback observability in place. So same model can produce two different product. So it is same like in backend distributed system, Redis, Kafka, database, search index, all these are not alone product. It depends how good it is wired within a system. LLM is a component, very intelligent component, but it is just a component, right? And if the system is weak, better model cannot save the product, because if retrieval brings the stale data, better model still see the stale data. If validation is missing, better model can still produce the unsupported results. And if observability is not there, then better model can still fail silently without leaving any traces to debug the system. So LLM is important, model is important, it gives intelligence to the system, but what gives guarantee to the user is the system built around the model. Model gives intelligence to the system, and the system which you build around the model gives guarantee to the user. And next is mental model for production AI system. Wrong mental model is user to model to answer, and that is demo thinking. Model generates the output, but the product decides whether that output is useful, safe, allowed, cheap enough, and observable. And that decision layer is where engineering happens. In real products, model can be wrong sometime. But when model is wrong, does the product fail safely? Does it ask clarifying questions? Does it refuse? It fall back? Does it block actions? And it logs enough log and traces for debugging? And that is the difference between demo AI and production AI. See you in the next one.